Welcome students. Today we are going to see linked list, a new data structure. We have seen linear list as well as operations on linear list. Today we are going to see linked list. Linked list. Linked list. Now, what is meant by linked list? What we have seen about linear list? Linear list is a linear collection of data elements such that every element is referenced respectively by an index set, where index set is a set of n consecutive numbers. So, once again we will see linear list. Say LA with a linear array 1, 2, 3, 4, 5. So this is the linear array or linear list. So here elements are A, B, C, L, M, N, O, P, Q, T, W, X, Q, W, Z, M, N, O. So these are the elements of list LA, where every element is represented respectively by an index set, where index set is a set of consecutive numbers. Now here, if someone asks which is the first element, then obviously which is shown by smallest index. So ABCD will be the first element. Now here, linked list. Linked list is collection of. Now, how it differs? Linked list, how it differs from linear array? Here, this is the list. 1, 2, 3, 4, 5, 6. So 5 elements are sufficient. So, LA with the now linked list, not a linear list. Suppose here is a Nanded, here is a Pune, here is a Aurangabad, Mumbai, Delhi. Now linked list, say LA is not a linear list, now it is a linked list. So linear list is a linear collection of data elements where every element is referenced respectively by an index set. So obviously first element will be shown by the smallest index, lower bound. But here in linear array, first element is shown by a variable called start. So suppose start is 4. So if smallest index is not referencing the first element, here first element is referred by a variable called start. So question arises, which one is next? So Nanded element itself will give the address of next. Suppose there is a 2 Aurangabad. So Aurangabad itself will give the address of third element, that is suppose Pune. Pune will give the address of next element, suppose Mumbai, and Mumbai will give the address of next element, suppose Delhi, and after Delhi there is no element, so address is none. Now what is the difference between linear list and linked list? Linear list is collection of elements where every element is referenced respectively by an index set. That's why obviously first element is shown by smallest index, that is 1. But here it is a linked list in which first element is shown by variable called start. So start is saying fourth element is the first element. So now that is the first element. So element itself will give the address of next, that is Aurangabad. Aurangabad itself will give the address of next Pune. Pune will give the address of next, that is Mumbai. Mumbai will give the address of next, that is Delhi. And Delhi says there is no further address. That's why this was the last element. That's why This is called as info part, that is information of element. Whereas you see start is equal to 4 is the non-date, so non-date is the information of element, whereas 2 will give the address of next element, so that's why it is called as link. And this combination of information part as well as link part is called as node. Thus, linked list is collection of nodes where each node is divided into two parts. That is, first part called info will give the information of element. And another part that is link or next pointer field. Will give the address of next node. Now, here logical diagram of the linked list can be drawn like this. A linked list is a linear collection of data elements called nodes, where linear order is given by means of pointer, where each node is divided into two parts. Now, a logical diagram can be shown like this. Say this is the node. So here is the info part. This is the info part. And this is the link part or next pointer. So it is shown by variable called star. Star is, so here it will give the address of next node. So here is the info part, it will give the address of next node. So here instead of saying, we will say dot. And suppose this is the last element, it will be shown like this. So information will be stored here, and every node will give not only the information about element but also link to next node. So this element not only give the about information of element but will give the link of next node, and this element will give the address, information about the element, and it will give the null address. So we have list finished. The pointer of last node contains special value. The pointer of last node contains special value. Now here you can first of all see this. This is about to inform me. Now look. Now we are going to see how to represent that. But before that, two things are essential. Linked list is collection of nodes. So first node is that node which is given by variable called start. and last node who will indicate the address of next node, that is null. The pointer of last node, the pointer of last node is denoted by or contain special value, Now what exactly mean by special value? As we have seen, there were 5 elements, 1, 2, 3, 4. Start was 4, then every element was giving the address of next node, every node was giving the address of next node. Last element was Delhi, that was containing address given by null. So any negative value can be given, because negative will not be the address of any memory location, called null pointer. Null pointer. So what is null pointer? Which is any invalid address. Invalid address. Here null pointer is in our diagram. Here null pointer is denoted by X. But in practical reality, address of next node is given by SH value, that may be the minus value. Linked list also contain the linked list also contain a pointer variable called star. Pointer variable called star, which will contain the address of first node, which will contain the address of first node in the list. It means that start will give the address of first node, and every node is divided into 2 parts. First part is the element, second part is the address. Now question arises, how to represent the list in computer's memory. So you take down this. Now question arises, how to represent the list in computer's memory. Representation of linked list in computer's memory. Representation of linked list in memory. Now we have seen linked list is collection of nodes where first part is info part, another part is link part. So if such type of 2 parallel arrays are there and one variable star is there and one a sentinel value, null value is there, 4 things are required. 2 parallel arrays, one variable start, one value. So let list be the linked list. Let list be the linked list. Let list be a linked list. Then how to store? Because first is the info part, second is the link part. Then list can be maintained in computer's memory using 2 linear arrays, then list can be maintained in memory by two linear arrays. Two linear arrays should be parallel. Why? First array will contain only info, and second array will contain addresses of next nodes. So that's why we'll name that, say, info and link. Such that info of K and link of K will give what it will give. Suppose K is 3. So info of 3 and next address of 3, whatever that. It means contain information part and next pointer field of node. Next pointer field of node. Now, list also require variable. Four things are required. Two parallel arrays, variable count. List also require a variable called star. For what? That contain the beginning location. That contain location of beginning of list. Beginning of list stand for first element and next point is element. Next point of sentinel. Sentinel stand for a such value that will use the denoted by null. Denoted by null. So how it will be represented? See, this is the info part. Info. This is link part. Y, E, S, H, W, A, N, T. Now, this is the link. Next point. Suppose star is equal to 1, 2, 3, 4, 5, 6, 7, 8. We can say Y, E, S, H, W, A, N, T. Suppose star is equal to 4. Then what is info of 4? Info of 4 is equal to 1. So link, suppose we are going to E 1. So link of 4 is 1, comma. link of 4 is equal to 1. So link of 4 is equal to 1. Now info of 1 is E. Info of 1 is equal to E. So link of E, suppose we are going to S, that is 7. Link of 7 is equal to, link of 1 is equal to 7. So info of 7, what? S. Suppose we are going to E now, H now, so it is a 3. So link of 7 is 3. Link of 7 is equal to 3. Now suppose info of 3, that is H. Info of 3 is equal to H. Link of 3, suppose we are going to W, that is 8, is equal to 8. Now info of 8, W. Info of 8 is equal to W. Suppose we are going to A now, so 2. Link of 8 is equal to 2. So info of 2 is A. Info of 2 is A. Now link of 2. Suppose we are going M. So it will be 6. Now info of 6 is N. Info of 6 is equal to N. So link of 6 we are going to suppose T. Link of 6 we are going to write T. So here 5. So info of 5 is T. T. But after T there is no one. Link of 5 is equal to null. So by this way we can prepare the list in computer's memory. So take down this. So this is the linked list and representation of linked list. Now two more articles are there, that is tree and pointer array. So today I think we will stop here. Thank you.